Good Friday. Anyway. Shut that down. Let me go ahead and log in here. It's right here. I'm coming, guys. Let's see the time. Just about ready to get started. Sign in. My poor little device is moving as fast as it can. Nice, we got past that. Calculus for business. We are still doing attendance, guys. So, you don't want that to be an issue. I try to make it as simple as possible, right? We're going to work here. And there are 150. I want to say give. There it is right there. We're going to start with question 53. Right there. Let me check one more thing before. That's that. I can expand it just a little bit. All right. That's going to have to work. Let me check it real quick. It's got to find it. Yep, looking good. This is like what I thought. Okay. No, I can't. Look at my device. Okay. All right, so people are trickling in. Let me just let it go. All right, let me go ahead and share my screen. Because we're at the end. I mean, I think pretty much whatever is going to be, whatever people are going to do is kind of done at this point. I'm supposed to update you guys' grades? I am. Let's start off here. No, because exam 2 is out right now. It's not you all. It's not the group. Okay. Yeah. So after Monday. Okay. So exam 2 is out, as usual. If you have questions, feel free to either unmute yourself or type in the chat or the Q&A. We'll make sure to get your inquiry addressed and resolved. And we're just going to kind of continue the review from Monday. Monday, I think we focus so exam 2 is going on right now. Monday, we focused on chapter 3, right, as far as a review. So today we'll focus on chapter 4. You can even ask questions from your exam. Like if you're on a question, you just want some support, we can work on it together. Like it'll be okay if you have questions. If you already done it and you're good to go, then, so be it. Right. And so this is a tentative schedule, right? I think after this class, we have 4 sessions remaining. And so each of those 4 sessions, we're going to be reviewing like a chapter, right? So on Monday is chapter 1. Wednesday is chapter 2. The following Monday is chapter 3. And then that last Wednesday, that 4th session, that's going to be chapter 4. Your final exam should become available. So we meet that Wednesday. Let me see if I can pull the date. So I'm under the impression. So yeah. That 30th, right? April 30th. I'm under the impression that April 30th is the last day of class, right? So we're going to review chapter 4 on that day in preparation for the final. May 1st and 2nd, that's the reading period. I want to say I made your final become available that Sunday. May the 4th be with you, right? So May the 4th, right? May the 4th be with you. National Star Wars Day. Okay, random story about Star Wars. You're on YouTube, you get random things that pop up in your feed. And somebody was like, it's been 30 years and I just realized something. And so they're like scrolling through Star Wars. I forget which episode, but like there's a scene where they're all in like this chamber. You have all the delegates or whatever. And they go to one chamber and there are these like brown alien creatures, right? And then he jumps over to E.T. and he was like, E.T., has force power, it can heal with his finger, yada, 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 it can make things levitate. He was like, these powers sound familiar. Come to find out, E.T. was a Jedi. And like, I was like, yo, that makes so much, because I remember seeing that in the movie. I was like, man, that looks like E.T. And I just shrugged it off. But yeah, so his claim was that E.T. is a Jedi. So just in light of May the 4th be with you coming up, right? So again, tentative schedule, we're reviewing for exam 2 today. And then for the 4 remaining sessions, a chapter per day. Also, I want to say course evaluations are out, so just be sure to submit those. And again, if you have questions, feel free to either unmute yourself or type in the chat or the Q&A, and we'll make sure to get it addressed. So yeah, that the reading period is May 1st and 2nd. Your final, I think I scheduled it for, again, Sunday, May the 4th at 11:11. It should become available. And then the hard deadline for all assignments, final exam included, is that Friday, May 9th at 11:59 p.m., right? So that's at the end of the week of finals. Week of finals was that first full week of May, right? So that Friday, May 9th is the hard deadline for all assignments. So this is a really good time to get caught up on missing assignments, either exams or quizzes or homework. This is a really good time to get caught up. If you need help, just you got to ask for it. Closed mouth don't get fed, right? If you don't say, and oftentimes whoever does the most talking does the most learning. That's the only reason I know this stuff, because I'll be talking about it day in and day out, right? So I probably should revamp my structure to get you guys a little bit more interactive, but I was just trying to find my own little rhythm until I'm ready to do that. So anyway, yeah, okay. So with that, let's go ahead and continue our review. So I did my little randomization thing, and we're going to start off with question 53. This comes from section 4.3, question 55, right? And they have us evaluating a definite integral. I think I am going to do this one. I'm going to write it out. Let me see. Do I need to write this one out? That's ln. I think let me try it here. I'm going to take some notes here. I probably should write it out. You know what? Let me just stop being like that. Let me stop. I don't know any of the lingo. I can barely say the word cap and pause. So I've released all that. I'm like, yeah, I'm good. I'm just going to be me, right? Take it or leave it, hate or love it. It's all good. Okay, so we're going to take that. And it's so weird, like what's been happening as a whole, or when I was a student at Morehouse, some of my classmates have been popping up, or former students of mine have been popping up. My former teachers from high school have popped up. I'm like, what is going on? Like everybody from the past has been popping up. I don't even know what that's about, but it's cool. We just exchange info, and it's good to see people. I love to see that everybody's doing well and like people's growth, and I love to hear their stories. It's always so interesting. But yeah, anywho, and it's inspirational. It just activates me. I'm like, okay, let's mix things up. Like, let's do something different. So anywho. All right. So we're evaluating the definite integral, right? So we're just going to take the integral like normal. Okay. These terms look reasonable, right? We got 2x. So the integral of 2x is what? X squared over 2. The 2's are going to cancel. So that integral for that term should just be what? X squared, right? And then now, is that a question? I'm not sure. Let's see what's going on here. I think somebody's just logging in. Yeah, you guys are good. Yeah, I'm gonna about that. Okay. So I want to say 6 over x or 1 over x is a special integral, because x to the minus 1, if you add 1, you can't add 1 to the exponent. So that integral ends up being the natural log of x. Yeah. So that one's going to be plus 6 natural log of x. And then we want to evaluate this as x goes from 1 to e. Okay. So we're going to plug in e, get an answer. Plug in 1, we get an answer. And then simplify it as much as we can. So if we plug in e, we'll get e squared. Natural log of e is 1. So then that's 1 times 6, which is just 6. So when we plug in e, we get that result. We're going to say minus when we plug in 1. 1 squared is 1. Natural log of 1 is 0, so that second term is gone, right? So then it's just minus 1 like that. So then if we put this together, what? E squared plus 5? Okay. Now, we get this result, right? I want to say in our TI-83 plus, we can actually check this guy before we submit it. That's honestly how I got most of my points. That's how I got through most of my math classes, is checking questions whenever possible. Because then you can convince yourself that it's correct, especially if you're in like a proctored environment, which I know we really haven't been in in here, but I'm just sharing this. You drastically lose the odds of success in your favor, right? So let's see if we can do this in the calculator before we submit it. Let's see. So we got this 2x plus 6 over x, right? Okay. So now we want to go to math that is located in stats. Calculate? No, not stat, but list. Let's try list. There it is. Math. Nope, not that one. Okay, this math over here. It's two different maths. There it is, number 9. Number 9, right? So we want to take the integral of that function. So I'm going to call on that function that we just had. With respect to x, as x goes from 1 to e. I'm going to do e to the power of 1, so it's just e. I think we're good. We should get some decimal, okay? And then what we want to do is take our result that we got here and make sure it's the same decimal, right? So we're going to say e squared plus 5, right? And we should get the same thing. And that's about the best we can do. Okay, so then let's hop back here. Exact answer in the form of e. So we want this guy. Put this down some. Okay. I think we got 5. So settings off. Okay. And maybe gonna work. Okay. E squared plus 5. Okay, let's check. Woohoo! Right? Okay. So that was fun. Let's do another one. All right. So let's go to question 90. Go to question 90. Right here. Right there. All right. So this comes from section 4.4. Let me zoom in some. Or matter of fact, maybe if I just do this instead, this might behave a little bit better. Okay. Find the average value over the given interval. I think they just mean like take the integral as x goes from 0 to 3, average value. It might be the integral divided by x. Let me look that up before. Yeah, because usually it's like the sum over x. I'm just going to view an example. Okay. Yeah, okay, so we were close. Right? So average value. The thing we were missing, we got the integral part, but we were missing the 1 over b minus a. I think we can take it from there. Okay. So 1 over b minus a. Let's get a screenshot of this. And again, how you saw me just use that view an example, that's the main reason why I push so hard for Pearson. The view an example, along with the other learning aids, but the view an example is the main one I think is the best for the students. You pretty much get a detailed explanation for like at least 90% of the questions. And if that's not enough and what you do with your classmates and the tutor isn't enough, then you hit the ask my instructor and then it'll send me a screenshot and I'll do a dedicated video response. Let's pull a copy of this. Right there.
So, one sauce.
Okay, let's try this again. Come on. All right, it's looking better. So we're gonna expand this guy. Okay, I think we're Gucci. Yeah, that's weird. I don't know what does that. Because everybody's muted. Like, I don't know. I don't know how that's getting through. But anyway. Okay, let's keep going. All right, so we just looked up how to find the average value. So now that we have the formula, here, let's write it real quick. So y average, 1 over b minus a times the integral as x goes from a to b of f of x dx, all right? That's essentially what we're going to be calculating. So then that's going to be what? 1 over 3. The integral is x goes from 0 to 3. We got this 3e to the negative x dx. Okay. All right. So with that constant, that 3 in front of the e, we can move that to the front. We can factor that out of the integral. Just pull it in front. So a third of 3, they're essentially going to cancel each other, right? So this is going to cancel this. E. Okay. So now I'm tempted because I know like e is its own derivative, so we can start with like e to dx, right? But the derivative of e to the negative x is what? A negative times e to the negative x. So I think we need an additional negative here like that. So now when we take the derivative, we get our desired result of e to the negative x. We want to evaluate this guy as x goes from 0 to 3. Okay. So then it looks like we get what? A negative e to the negative 3. E to the 0 is what? A 1. So double negative is a plus 1. I'm just going to rearrange it. 1 minus e to the negative 3. We could check in our calculator. I think for the sake of time, I'm just going to go with it. 1 minus e to the negative 3. Average value. We got 1 minus e to the negative 3. So let's zoom back out. I think that does work a little bit better. I have an exact answer. 1 minus e to the power of negative 3. Woohoo! All right. All right. Just stop me if I'm moving too fast or if anything isn't clear. Let's generate. Let's go to question 41. I feel like I'm doing like a podcast, you know, the way I do it. This is, but that's all I listen to half the time, just like podcasts and just reaction videos, you know. Anywho, all right. So find the area under the given curve over the indicated interval. I guess that just means take the interval. What is it? X to the 4 over 4. Evaluate it as x goes from 2 to 5. Let me see. X to the power of 4 over 4. So then when we plug in 5, what is it? 625 over 4? All right. 625 over 4 minus 16 over 4. I'm going to leave it at 16 over 4 for right now. All right. 625, 615, 610, 609 over 4. I think we could probably go with that. I'm going to go with that. All right. Because the integral of x cubed is x to the 4 over 4, right? And then we want to evaluate that as x goes from 2 to 5. So we plug in 5, we get an answer. Minus, we plug in 2, we get an answer. And the answer I got after doing that was 609 over 4. I'm going to go with that. Okay. All right. I don't know why my mind, I can tell you why my mind is so clear and I got so much energy. I've been doing those workouts. Man, whoo, those things are wild. So there's a group, there's a group called Hills for Atlanta. Man, oh man. Whoo, they got you like running up hills at Piedmont Park. Oh man, that thing is wild. But it'll get you right. Like it took me about a month before, like 4 sessions before I could do the whole. Like today was the first day I did the whole workout. But yeah, I was like, that's why my mind is so clear. I was like, I don't usually feel like this. I was like, oh, that's what it is. Not that it's a bad thing. I was just trying to figure out why do I feel so good. I was like, oh, because I've been working out for a change instead of being such a couch potato, which is so easy to do. Find the area between the curve and the x-axis over the indicated interval. Okay, we're going to take some notes on this one. We're going to take some notes here. Okay, let me get a screenshot. All right. So then what I like to do. the upper curve minus the lower curve. I'm assuming, I guess I need to when x is 2, it should be above, right? 3 minus 0. Yeah. So I was just trying to make sure that this curve is above the x-axis on this interval, right? And I think it is. So, okay. So we're going to do the integral as x goes from 1 to 10, the upper minus the lower. So we're going to say this 6 over x minus x, all right, dx. Okay. So I think that it's kind of similar to something we did earlier. The first one should be what? Natural log. So 6 times the natural log of x minus x squared over 2 as x goes from 1 to 10. Okay. Natural log of 10. We'll just leave that number. So we're going to have 6 times the natural log of 10. 100 divided by 10. Wait a minute. X squared over 2, right? Right here. It's supposed to be x squared over 2. So 100 divided by 2 is 50. So when I plug in 10, I got this result. Minus, when we plug in 1, natural log of 1 is 0. So minus, so double negative is a positive. I think that's a half. Okay. $49.5. So we got what, 6 times the natural log of 10 minus 49.5. So that's an exact result, and then we can use our calculator to get a decimal approximation. All right. All right, type in exact answer. 6 times the natural log of 10 minus 49.5. Let me see. Yeah, we did that. Okay, let's go back. Let's look and see. That shouldn't make a difference. Okay, minus x, right? Oh, the x-axis is 0, right? So we don't need that minus x. That's what's throwing things off, right? Yeah. Yeah, because y equals x is a diagonal line. So I think that's supposed to be a 0. I think that's where we made our mistake. Okay. Let me think. Yeah, right here. So I think that this guy was supposed to be a 0. So I think we just take the integral like normal. So then that means this is gone. All right. That means this is gone. I think this is gone as well. Let me write it. So I'll kind of start from like here. So I think that 6 natural log of x is good. We want to evaluate that as x goes from 1 to 10, right? If we plug in 10, that's going to be 6 natural log of 10. And then the natural log of 1 is 0. So I think that this is the result. I thought it looked a little strange, but I figure if we make a mistake, we'll get to the bottom of it. All right. Okay, so we just got 6 times the natural log of 10. And see, if I had checked it in my calculator, I would have caught the mistake and not wasted one of my trials. But you live and you learn. Let's see that we get it this time. 6 natural log of 10. Okay, yeah. So again, the thing there, the x-axis is just y equals 0. So that was supposed to be a 0 and not x. Okay. All right. Well, we are rocking and rolling, moving and grooving. But hope you guys are all aboard and not all bored, right? Because I know this stuff will be boring, especially if I don't know. All right, let's go to question 80. Let's go to question 80. Way down, show. All right. All right, this comes to section 4.4, question 16. We have something that says find the area of the region bound by the graphs of the given equations. X to the power of 5 and 81x from 0 to 3. So for instance, when x is 2, 2 times 81 is what, 162. 2 to the power of 5 is what, 32? So that means the upper image is the 81 and the lower is the x to the power of 5. Is that correct? 9 times 9. Or do we have to... We might... Okay, I think we might go a little bit deeper because 3 to the power of 5, look, it goes... Let me see. Let me think. 9 times 9 is 81 times 3. Oh, they meet. That's where they meet. Okay. So yeah. I think the first equation is above the second one. Right. I just kind of chose some test points, right? I think they meet at 0. They meet when x is 3. So then I was like, okay, when x is 2, it looks like the left one is higher. When x is 1, the left one is higher, right? So the left one is, we got to say the upper minus the lower. Yeah. I mean, honestly, I don't really feel like I need to write this. So now I feel like I can do it here. Okay. Let me see. It's probably the best idea. Let me stop being lazy. Just do what I need to do. Be easy on myself. Because the minute I start trying to take notes here and like Pearson, then my chances of make a mistake increases exponentially. So I'm more likely to make a mistake. All right. Go here. Come on. Try again. I knew I needed to be moving more, and I'm just glad that I finally just started moving more. I kind of had to change the people I was hanging around a bit. And then I was like, okay, just get it out. Okay. So we want the area bound by the two regions. So we want to take the integral as x goes from 0 to 3. The upper minus the lower, so that's going to be 81x minus x to the power of 5 dx. Okay. So the net integral, what is that? 81x squared over 2. And then minus x to the power of 6 over 6 as x goes from 0 to 3. I feel like that looks okay. Let me see. There's a 9 times 8 is what? 72? 72. So it's 9 times 9 times 9. 81 times 9. 81 times 9. Wait a minute. Is that what I just did? Over 6. When I plug in 3, I get something like this. 0 collapses to 0, so we just need to simplify this guy. 11 and 7 is 18. I think that is divisible by 3. Okay. Obviously, we could just use our calculator, so you don't have to do what I'm doing. I'm going to factor out a 3 on that, the one on the right. So let me see. There's a 2. 12 is a 4. 3 over 2. All right. Okay. 6, 12, 6 and 2 is 8. That's a 6 minus 2 is a 4 over 2. 2, 4, 3. Okay. Oh, you know what? We can check it. I'm getting these notifications. Okay. So, let me check it here. All right. So what I'm going to do is go to my y equals. What time is it? So we go 81x minus x to the power of 5. Okay. And I think I can recall what I had before. I don't think it was that far back. We want the integral of that function with respect to x as x goes from 0 to 3. So 0 there. 3 there. And we got to get rid of the extra stuff like that. And that one as well. Okay. And we should get 243. Awesome. $243. Let's go with 243. Let's keep going. Generate. We'll go to question 19. It just dawned on me that my weekend is about to start. Now it's like my mind is slipping into weekend mode. It's so bad, man. I go through this like every year, all the time. It's such a struggle. Okay. Find f such that f prime is this and f of 0 is 4. Okay, so basically take the integral, and they gave us an initial condition. This comes from section 4.1, question 51, so this is like one of the first ones. Matter of fact, I think I'm going to just work here, right? Because the integral, that should be an x cubed over 3, so I'm going to type it as like 7x cubed over 3, right? 7x squared over 2, so plus 7x squared over 2 minus 5x. Now, normally we say plus a constant, right? So plus some c. But it also says that when x is 0, the corresponding y is 4. So for those terms that have x, they all collapse 0. So that means that c equals 4, right? Because when x is 0, the only thing that's left, we have c equals 4, right? So I'm going to let c be 4. I don't see why not. Notice that when x is 0, we get a result of 4. When we take the derivative, we should get that above result. So I think I'm just going to go with this. I can't see anything else. Let me check on you guys in Zoom real quick. Okay. Oh, okay. We got some people that showed up. Okay. I was getting nervous. I was like, come on, guys. I don't know how to make it any more easy. But you're here, so we're good. Yeah. Not that I'm trying to intentionally make it easy. It's just how it's kind of unfolding. Anyway, the chat looks good. Do I have a Q&A? I do have a Q&A. Okay, I think you guys are okay. Let's keep it moving. Participants and suppress. Okay. All right, let's generate. Let's go to question 102. When I had to tie my shoe, then my nose I blew and went a chew. Okay, that's enough, Robin. Just all right. Let's see. This comes to section 4.4. I don't know what ACQ stands for, something, but anyway, find the area bound by the graphs of the indicated equations. X equals -2. Okay, I see. X equals 2. Now, let me think about this. So this is as x goes from -2 to 2, and then you got to say the upper minus the lower. F is the upper and G is the lower. Okay, I think we got this. Oh, they want us to fill in the information. So x goes from -2 to 2. So we're basically going to do f of x minus g of x. All right. So right here, the upper minus the lower. So we're going to have that 3x squared plus 3 minus, so double negative is a positive, 3x squared minus 2 Okay. We can combine like terms. 3 and 3 is a 6x squared. 3 minus 2 is plus 1. Let's get rid of our notes. All I did was say f of x minus g of x. Complete the boxes. Type an expression involving x. No, wait a minute. Oh, okay. Let's go like this. So when we take the integral, okay, 6x cubed over 3. So 2x cubed. Let's see, 2x cubed plus x. Mute. Okay. X cubed over 3. 6 divided by 3 is a 2. There's x. That looks good. This thing is throwing a tantrum. When we plug in 2, basically 2 to the power 4. 4 times 4 is 16. Plus 2 is 18. That's 18 there. When we plug in negative 2, 16, I think that's a negative 16 minus 2. I think that's a negative 18 right there. Negative 18. So double negative is positive. So what is that, 36? Nice. I swear, when I started this question, it said 6:36. It's like the clock did not move. Okay, we're not done. So due to symmetry, you could also have found the same area using the integral. I don't know. You can check your answer with the fn int. Okay, function integer. Symmetry. Well, it has y-axis symmetry. So two times. Oh, okay. As x goes from 0 to 2. Okay. That's excessive for like no reason. So because it's symmetrical about the y-axis, you could just focus on the right-hand side. I just got to think about how to do it. As x goes from 0 to 2. So if we set the upper minus the lower, how are we going to find that guy? I mean, I guess so. Okay. I think it's going to be the same thing, right? Because the limit of integration is it should restrict it to the domain that we want. Let's go with 6x squared plus 1. I think it's the same thing. That doesn't work. We'll figure it out. Oh, that was it. All right. So we still did our, what happened there? We still did our f of x minus g of x. We said the upper minus the lower. And then using the fact that it's symmetric about the y-axis, they kind of like cut it in half. So instead of doing from negative 2 to 2, they said 2 times from 0 to 2, right? And then everything else kind of stayed the same. That was an interesting little twist. Okay. All right, let's generate. Oh, question 3. Okay. If you're doing this kind of late, then you know exam 2 is out, so this is a review for exam 2. You can ask questions from the exam. I tried to alert you during like the last class. If you have questions, you can come to class with questions and we can work on it together. It can be about anything, your exam, old assignment, you know. But I just do this kind of stuff just to kind of fill the dead space.
But you know, Professor, when's the exam close? It's Monday, right?
This exam, yeah. So okay, yeah. Let me review that. So exam 2 is available now. It is due on Monday. You know, with all of our assignments, there is an automatic extension built into it.
Oh
The hard,
yeah.
we are approaching the hard deadline. The hard deadline for all assignments is at the end of the week of finals. So
All
that's
right. Yeah. All right. Cool.
yeah.
Thanks.
Uh-huh. That's the end of that first full week of May, which is May 9th. That Friday, May 9th at 11:59 p.m. That's the hard deadline for all assignments. So yeah, that's a good question. Yeah, also, if you joined us late, I finally okay. Let me kind of review the schedule because I noticed that, like when we did this earlier, there wasn't too many people here. Um, so yeah, we're reviewing for exam 2 right now. Focus on chapter 4 today. We have our weekend and we come back. So after today, we have 4 sessions remaining. So each of the 4 sessions, we're going to review a chapter, right? So Monday, this upcoming Monday, we'll focus in preparation for the final. So this upcoming Monday is chapter 1, Wednesday is chapter 2. The following Monday is chapter 3. The following Wednesday is chapter 4, which is April the 30th. I'm also under the impression that's our last day of class, right? That's going to be our last day together live like this. So that'll be April 30th. That May 1st and 2nd is the reading period. And then your final exam should become available on that Sunday, May the 4th be with you. That is National Star Wars Day. We had a little bit of anecdote about how E.T. is a Jedi. So, you know, there's a little short about it. It was kind of interesting. I was like, oh, okay, I can see it. But yeah, your final exam should become available that Sunday, May the 4th be with you at 11:11 a.m. And then it's due that Friday, May 9th, which again is the hard deadline for all assignments at 11:59 p.m. Right. So if you haven't got caught up, this is a good time to get caught up. And then more than likely, usually, and I'll try to, I do intend to try to update you all's grades after this upcoming Monday, so that you can have a sense going into the final of what you need to do. Uh, Generally, you know, you want to try to create as much of a cushion as possible. You have to check the syllabus for the weight of the final. I think it's like 20%. It's either 20% or 30%, whatever's on the syllabus. That's the weight of the final. So yeah, everybody has to take the final, even if you have an A. Like I know that sometimes students look, well, I have an A. Do I have to take the final? I was like, yes, yeah, you still got to take it because without the final, the highest you can earn is like either a 70 or 80, right? And you don't want to be at an A and then have to settle for either a 70 or 80. So everybody has to take the final. Um, you know, unlimited attempts, all that kind of stuff. So I felt like there was something else I wanted to share. Oh, so yeah, my intent is to update grades after Monday, and then at the end of the semester, I usually don't calculate my final grades until that Monday after the week of finals. Sometimes I have extensions until that Sunday night, but definitely by that Monday, just like May 12th, I'll be calculating final grades. I mean, once you, the idea or the goal is, you know, you want to try to go ahead and complete all of your assignments, homework, quizzes, exams. You want to try to finish everything. So that way, when you take the final exam and you finish, you should be done with the course, right? You don't want to take the final exam and then be trying to submit more assignments, right? That's not a good look. The goal or the intent is when you submit your final exam, that's it. All right, just release it. So you know, the recommendation is to go ahead and you know, get caught up right now. Also, course evaluations are out if you haven't done so already. So just be sure to submit your course evaluations. It should be in your student email, and I'm pretty sure there's some other place you can access it as well. Maybe either Bannerweb or Blackboard, but it's definitely in your student email. Okay. All right. So let's keep going. I'm glad you asked these questions. Let's see. Evaluate. This comes from section 4.1. So it looks like we just add 1 to the power and divide by the new power. So what is it going to be? 11? 11 over 5 over, okay, let me type it out. So x to the power of 11 over 5, and then all divided by 11 over 5, plus some constant. And then we would like flip and multiply, right? So 5x to the power of 11 over 5 over 11 plus some constant. think that's about it. I can't think of anything else there. Right? It's weird, but what it is. Okay, let's generate. Let's go to question 78. 78 is here. Okay. Find the area of the shaded region. So normally we do the upper minus the lower. We might need to break it into multiple integrals, right? Because again, we want to do the upper minus the lower, and so it changes at the origin. So the first integral is going to have g is going to be g minus f from as x goes from -4 to 0, and then plus f minus g as x goes from 0 to 2. Okay, that's at least when I look at it now. That's what my intuition tells me. That's what I'm going to go with. Yeah. Let's just see if that works. That should work. Right there. Got it. Okay. All right, we are here. Okay, find the area of the shaded region. So we're doing the integral as x. I really feel like we can. I feel like there might be a better way, but I just want to try this anyway. So if we said the upper minus the lower, right? So as x goes from where -4 to 0, it's going to be g minus f. So it's going to be, we got to distribute a negative across that thing. So then that's going to become what? X cubed plus x squared minus 12x dx. Plus the integral as x goes from where? 0 to 2. We're going to say f minus g. So then just f as it is. And let's kind of go like this. 12x minus x squared minus x cubed dx. Okay. Okay, let's see what happens. So the first integral, what is that? X to the 4 over 4, x cubed over 3, x squared over 2, so 6x squared, as x goes from -4 to 0. 12x squared over 2, so 6x squared. X cubed over 3. X to the 4 over 4, as x goes from 0 to 2. Okay. When we plug in 0, everything is gone. So we're going to say minus when we plug in 4. Sorry. Upper minus the lower, right? When we plug in -4, 16, I don't know that one. Is it 220? It can't be 225. Let's just put that here. 4, 2. It can't be good. I don't know what it is. 256. That's what it is. So 256 over 4. 16 is going to be a negative. 16 times 4 is 40 plus 24 is 64. Sixteen times 6 is 60 plus 36, 96. Yeah, it's just 96 there. So keeping track of our signs, right? Okay, so we said the upper minus the lower, then we're going to say plus the upper here. 4 times 6 is what, 24? 8 over 3. 16 over 4 is just 4. When we plug in 0, everything is gone. So then it's just this. So then we kind of just need to simplify. 16, okay. So let's see. Is what, 6? 16 is a 4. 4. And hopefully we got these numbers proper. 56 over 3 is 11. So this turns this into what, like a 20, right? Let me see. This turns this into what, negative 44? 50, 46, 52. Okay. 46. So this turns this into a 52. Okay. Let's keep going. 52. Let me see. 60, 56. So plus 56 over 3. Okay. 156. You didn't have to do all this. I was thinking using calculator. I don't know why I did it. That would be 212. 5. Let's see. What time is it? Okay. 212 over 3. Let's see. You know what? Before we submit it, I'm just going to submit it. Because if we set it up incorrectly, then, you know, we can't, we'll struggle to check it properly. We got 212 over 3, I think. Come on. Let's try 212 over 3. If that doesn't work, then we'll get to the bottom of it. Simplified fraction. 212 over 3. Okay. Go ahead and simplify this real quick. So then 3 into 21 is a 7. Zero and 2/3. Simplified fraction. That's a mixed fraction. Maybe the 212 over 3 will work. Try 212 over 3. 212 over 3. That was an adventure. I don't know why I just couldn't. I could have easily just like took out the calculator, but that means we understood the concept, right? Because again, when you're saying the area between, the main thing is like when you're doing the area between two curves, you got to say the upper minus the lower. And every time we would do it, I would think, well, what happens when it crosses, right? And this is just a simple case when I'm thinking like, okay, well, what if it like crossed a whole bunch? Like it kept oscillating around it. Like how would you capture that? But for this specific case, we broke it into 2 separate intervals, right? So that was an adventure. We still got a solid 20 minutes, so I wanna hang out for at least 10 to 15. We might not go all the way, but at least 10 more minutes. Let's go to question 94. Let's go to question 94. So hopefully, I guess you guys keep showing up. So I was like, hopefully you guys are getting something from this. Let's see. Let me zoom in on this one a bit. So this comes from section 4.4, question 51. I think SS might stand for either social studies or social science, something like that. I'm just guessing on the abbreviation, but that's irrelevant. In a memory experiment, Alice is able to memorize words at a rate given by this equation here. In the same memory experiment, Ben is able to memorize words at a rate given by this one. In prime. Who has the higher rate of memorization? Which is above memory experiment? Was that like, what are the units? What if I let T be 1, the higher rate? Because I'm tempted to say like 1 minus the other. Let me see. If I put a 1 there, I just don't feel like crunching it. I'm being totally lazy in my mind. We could look at the graph. I'm going to see what the book did. I'm going to give you an example. Since the given functions are the race of two people, compare the graphs. Yeah, so they say compare the graphs, right? Okay, so in this, you see M prime. So yeah, they just looked at, and we said that. We just didn't follow up with it. I think just for the sake of time, I'm just going to assume that it's similar. We can look at the graph. I'm being lazy. Like I told you, my mind is already. We only got like less than 10 minutes. My mind is already in weekend mode. I'm like, choo 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 choo. Okay, so we'll do the first one in slot 1, right? Negative 0.012 x squared plus 0.3 x. Okay. Negative 0.003 x squared, 0.3 x. Okay. We need a window. Let me I want to see what window do they have. So 3 and 10. Okay. Let's go from like -2 to 10. Y minimum. We can go like -2. I'm going to do a similar window to what they did. I want to go in steps of a half on this axis. Okay. So then we got to figure out which is which. So I think we can use trace. All right. Let me see. If I go, this one is the 0.12. So whichever one is not 0.12 is the higher one, the higher rate. So that's the capital M, which is bin. If we guess, we had a 50-50 chance, but chance favors the prepared mind, right? Okay. I'm probably gonna make this the last one. We're gonna try to wrap this one up and call it a day. Let's zoom out. How many more words does that person memorize from 0 to 10 during the first 10 minutes of the experiment? Yeah, so I think what we're gonna do is take the integral as t goes from 0 to 10 of Ben minus Alice. Man, I just don't feel like doing this either. Being lazy. Okay, but we got it. We know what to do. Let's just do it. Stop making excuses and just knock it out, all right? Just get it over with. All right. So, and I feel like the hardest part is over, right? Because now that we know who's higher, so then it's kind of like similar to what we've been doing already. It's just we're dealing with decimals, but it's not really that different than anything that we've been doing. Okay. I think it said the first 10 minutes. So we want to take the integral as t goes from 0 to 10. Ben minus Alice. So that's going to be this negative 0.003 t squared, 0.3t, minus Alice. So we got to distribute negatives. So negative 0.012 t squared plus 0.3t dt. I'm kind of running out of space. That looks decent. So some space. Oh, you're doing that thing. Okay, see what I need to do. Let's just rewrite that. T, let's try this again. T dt. Okay. Let's simplify this before we take the integral. We do have like terms there. So let me let's do it like this. 0.003 t squared, 0.3t plus 0.012 t squared minus 0.3t. I'll just put dt like this. We combine like terms, right? We subtract those. So 12 minus 3 is what, 9? 0 009? I think it's 009, right? So that's going to be 0.009 t squared. T and t, looks like those guys cancel. Like this cancels that. So then it's just a dt there. Okay, that drastically simplifies it. Okay. So then that becomes 0.009 t cubed over 3 as t goes from 0 to 10. Okay. Hundreds or 1,000. So move the decimal to the right by 3. 1, 2, 3. So 9 divided by 3 is a 3. So when we plug in 10, we got a result of 3. When we plug in 0, we get a result of 0. So 3 minus 0, we get 3. Now we could check this in the calculator. Let me show you. Let's see how to check this in the calculator again. This will be our last one. So like how I would check this in my calculator. I'll go to my y equals. So you see how those are already there. We did the second one first. So we said the second minus the first one. So then what I would do, let me see if I can, I'm gonna go to my math, the function integral number 9. I want to take the integral of the second one minus the first one. So maybe I need to put it in parentheses. So then I want to say the second one minus, hopefully this works, the first one with respect to x, I need a comma, with respect to x as x goes from 0 to 10. Okay, we should get 3. You did it right. All right, so I mean that we can kind of go with that. 3 more words. 3. All right, I think I am done. What else we got? Over the first 10 minutes of the experiment, on average, how many words per minute did Alice memorize, right? So average was 1 over b minus a. For Alice, Alice was the second one, right? Here. So then for part C, 1 over, so 1 over 10 times the integral as x goes from 0 to 10 of Alice, negative 0.012 t squared plus 0.3t dt. Right. So the average value, yeah, let's just go with it. So then we take the integral t cubed over 3 t cubed over 3 t squared over 2 as t goes from 0 to 10. So when we plug in 0, it's going to be gone. So we really just do it when t is 10. Move the decimal to the right by 3. So this 12 divided by 3 is a negative 4. 100. So move the decimal to the right by 2 is a 30. Divided by 2 is 15. 11. I'm getting 11 over 10. Words per minute? I'm assuming it's words per minute. All right, let's just go with it. All right, yeah, let's see if it works. So we got 11 over 10. So 11 words in 10 minutes kind of thing. Per minute. We got 11 over 10. Let's go with 11 over 10. Okay. They are just dragging this out for like no reason. That's where I have to be the laziest. Okay, we know what to do. It's just it's pretty much the same thing. We just gotta substitute Ben for Alice. Okay, so what I'll do, I'm gonna cut this. Shoot. Things off. Just a 2. Oh, so close. Okay, the bottom of the 2. Like that. There we go. Okay, so let's paste. So we want the integral as t goes from 0 to 10, 1 over 10. I think that's it, dt. This is like part D. This was correct. Let's see. 10 t cubed over 3 t squared over 2, 0 to 10. Move it to the, so that's just t cubed. $30 divided by 2 is a 15. We plug in 10. That's 1,000. So that's 3 divided by 3. That's a 1. $16. Looks like we're getting 16 over 10. 8 over 5. Okay. Word per minute. Longer than I anticipated, but that's okay. As long as we get it right. 8 over 5. Come on. Come on. Let's go. Let's go. 8 over 5. 8 over 5. Cross our fingers. We should get it. Oh, come on. Let's figure out where we made a mistake. Ben. Negative. Maybe I forgot the negative. I think I did forget the negative. Yeah, instead of 16, it should be 14. I did forget my negative right here. So instead of 16, that'll be 14 over 10, 7 over 5. Okay. 7 over 5. Okay, not too bad. With 5 minutes to spare. Okay. All right, gentlemen. So yeah, we kind of did announcements. Again, exam 2 is due on Monday. We kind of talked about anything. Are there any burning questions before we go our separate ways? Going once, going twice. All right, gentlemen. So yeah, again, we're going to be reviewing from here on out. We have 4 sessions remaining. Each session, we're going to focus on the chapter in preparation for the final. All right. Due dates are there, and just do your best to try to submit everything before the hard. Well, you have to submit everything before the hard deadline. If there are any burning questions, we're going to end the session here. Now, from one beautiful mind to another. Have a great weekend, gentlemen, and we'll start our review on Monday. Take care. Peace.
Looks amazing. I've been saving some vacation money in my work.
Right, take care. Take care. Feel like I need some outro music. Anyhow. All right, guys. Have a good weekend. Let me check.